Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Welcome to my channel. Today's topic is young modules from these solids. Step by step, I will explain to you very useful concept for mains exam as well as NEET examination. Young modules. It is defined as a ratio of longitudinal stress to the longitudinal strain. Considering this is the bar of length L. One end is connecting to the rigid support and another end is F force applied downward direction. Due to this force, the body, that is rod, get elongated. Length is delta L. Delta L is the elongation. L is the initial length of the rod and total length of the rod is L plus delta L. Now young modules Y, which is equal to longitudinal stress, that is restoring force per unit area. So F divided by A whole divided by longitudinal strain, that is change in dimension to the original dimension. Here in longitudinal strain we will discuss, that is change in length to the original length. Now we can write this equation Y, which is equal to FL divided by A into delta L. Here Y is the young modules. Okay, A is the area of the rod. A is the area of the rod. And continuation next, this is the second diagram here. This is the string of radius R, which is connecting to the rigid support, and second end is connected to the mass M is suspended. Now downward direction gravitational force mg is acting due to the load. Here elongation takes place. That elongation is taken as delta L and initial length is L. So initial length is L and elongation is delta L. So we can write here F, which is equal to, here force I am writing mg divided by area divided by delta L divided by L. So we can write second equation Y, which is equal to mg L divided by A into delta L. Okay, these two formulas we will use to solve the applications, and continuation I will explain. Just a second, I will clean the board. And continuation, now considering this is the string of length is small l and connected to the rigid support, second end is connected to a mass m. Due to the mass downward direction, force acting F is equal to mg, that is gravitational force. Due to the force, the body get elongated, nothing but string is elongated. So E is the elongation. Here area of the wire is A and pi r square r is the radius. See, young modules Y, which is equal to force divided by area divided by E divided by L. Okay, longitudinal stress by longitudinal strain. So Y, which is equal to FL by EA. Okay, so Y, which is equal to FL by EA multiplying and dividing with L. Now the relation with volume and length in the young modules equation. So area into length, that give the volume. So young modules Y, which is equal to FL square divided by E into volume. Okay, so we can write density rho is equal to mass by volume, where volume is equal to mass divided by density rho. Rho is the density here. Now continuation next, this value is replaced in this equation. So young modules which is equal to FL square divided by E into volume is mass divided by density. Here I am writing. Okay, so next step, using the basic formula Young modules. So Y which is equal to FL divided by EA, and now multiplying and dividing with area. So the resultant equation Y which is equal to F area into length is volume divided by A into E into A square. Now the relation Young modules with volume and area. Here relation with length and volume. Try to understand the steps, and again here I am going to replace volume which is equal to mass by density. So here this volume is replaced in the above equation. The resultant equation Young modules Y which is equal to F m divided by EA square into rho. Okay, here A is equal to area, that value is pi r square, and continuation Young modules Y which is equal to Fm divided by E pi square r to the power of 4 into rho. Here this value is replaced in the above equation. So then if Y value, F value and M and also rho is constant and rho are constants, then elongation is inversely proportional to the A square, and elongation is inversely proportional to the r to the power of 4. Okay, just a second, I will come back. See now, continuation here. First formula, that is Young modules is equal to FL divided by EA, we got from the diagram. And here the next relation I wanted to write Young modules in the form of length and volume. That's why multiplying and dividing with L, we got Young modules Y which is equal to FL square by EV. V is the volume which is replaced from the density, rho is equal to m by v. We got FL square rho divided by EM. Okay, next I wanted to write Young modules in the form of area and volume. So multiplying and dividing with area, then we got FV divided by EA square. Again I am replacing here volume is equal to mass by density. In this equation area is equal to pi r square. This is the final equation. Okay, so if Y Young modules force and M mass and density are constant, here elongation is inversely proportional to the square of the area. If area is decreases, then elongation is increases. Then elongation also inversely proportional to the r to the power of 4, because of area square is pi r square whole square. That's why here we got 1 by r to the power of 4. Okay, just a second, I will come back with another application. And one of the application, see, first I am considering this is the string of length L which is suspended in air. Okay, air as a medium, and m is the mass, another in the connected downward direction mg acting. F is equal to mg, and elongation is e due to the m mass suspended from the wire. See now, continuation here, Young modules y is equal to fl divided by ea. Okay, so continuation Young modules which is equal to fl is mg. okay, L divided by A and elongation by length, which is equal to mg divided by y into A. So we got elongation equation is taken as 1. Okay, and continuation next in water, nothing but taken as a liquid. So next in the liquid, we are doing experiment in the liquid. Same, okay, instrument which is takes place in the water, nothing but liquid. Then what happened here? Upward direction buoyancy force is acting and downward direction mg weight acting. Buoyancy force is always act upward direction on the body in a liquid. So the net force we have to find here. Due to this, elongation is E dash. So L is the initial length, elongation is E dash. Okay, so that's why there is a decreasing in elongation because of upward direction buoyancy forces takes place. Now in liquid, here net force F net, which is equal to mg acting downward direction minus buoyancy force is Fb. So F net, which is equal to mg minus buoyancy force is rho Vb. So this is the density of the liquid. Rho L is the density of the liquid and rho M is the density of the body. Okay, so I want to replace from the density rho B, which is equal to M by V. So V is equal to M by rho B. So F net, which is equal to mg minus rho L mb divided by rho B, and F net force in the liquid, that is mg common 1 minus rho L divided by rho B. Okay, we got net force. Now continuation, I wanted to find the elongation in the liquid. E dash is less than to the E. E is elongation in air, E dash is elongation in the liquid. E dash is less than. Why? Because of buoyancy force is acting, so net force is decreases. That's why elongation is less here. We will get that relation also. Now here Young modulus formula for the liquid, which is equal to Fl divided by E dash into A. From this equation we can write E dash by L, which is equal to F net divided by Y into A. Here F is what taken? F net force. F net force value already we got, just I am replacing that value. Okay, so E dash by L, which is equal to F net value is mg 1 minus rho L divided by rho B whole divided by the value is Ya. This is taken as equation number 2. Now equation 1 in equation 2. So E dash by L, which is equal to mg by Ya is E by L 1 minus rho L divided by rho B. Rho L divided by rho B. So LL is get cancelled. Here elongation E dash, which is equal to E minus 1 minus rho L divided by rho B. See, E dash is less than to the E. Okay, please do like and subscribe my channel. I will do continuation videos.